back, everyone. What we're going to be discussing today is the last part of the lesson, 4.D, systems of equations. This is a tricky one, but not too difficult. Now, at the end of today, you're going to be able to solve for missing unknowns in systems of equations. That means multiple equations, okay? You're going to determine the equation models from graphs and be able to understand the relationships from points on a graph. Now, this is all in your book from page 89 to 93, and it would be very useful if you did have your calculators today. You're going to definitely need them. All right, so let us begin with a system of equation. When we construct mathematical models, we can use the knowledge, all right, of math functions to guess the blank the model should take. What do you think the word is? The word is the form. So what form does our model want to take? For example, when a ball is thrown in the air, we can predict that its height above the ground, what its height is above the ground. And it can be modeled by a function in the form of at cubed plus bt squared plus ct, where t is the, what do you think t stands for? Blank in seconds, the time in seconds. And a, b, and c, what we're solving for here, are going to be unknown blank or blank. What do you think those two words are? They're going to be unknown coefficients or unknown parameters. All right, so those are the numbers that go here. So A, B, and C are actually numbers. We're going to figure out what those numbers are. We're going to do it by taking multiple tests of that height of the ball at different points. All right. So let's have a quick discussion. What do we mean by a coefficient, by a parameter, and by a constant? Aren't they the same thing? Well, they're a little bit different. All right. So the first thing you need to know is we can use these math terms interchangeable so we don't cause confusion. That's what we want to do. Coefficients, numerical or constant quantities placed before and multiplying the variable on an algebraic equation. So coefficients pretty much are the numbers that come before the letters in an equation. That's a crazy thing there. And if it's just a number by itself, it's also a coefficient because technically that number is in front of x to the 0 power, which is 1. A parameter, slightly different, pretty much the same. That's a quantity whose value is selected for that particular circumstance. So your parameter is like a section that you want to do, like from 0 to 50 seconds. That's your parameter. All right? And it's in relation to the other variables and quantities expressed. So it's related to the coefficients, but the parameters deal more with like a window that you're dealing with in numbers. If we have some data values that model the needs to fit, that the model needs to fit, long day of teaching today, we can substitute the points to the function and construct a blank for the unknown parameters. What do you think you can construct? I'll give you a hint. System of equation, all right? So in that system of equation, I went out of order here, is a collection of one or more equations containing the same set of variables, okay? So, when you have one or more equations, so for instance, y equals 3x plus 7, y equals 7x plus 2. That's two equations. Y equals 9x plus 13. Three equations. They're going to be related, okay? So when those systems of equations pertain to the same data set, to the same things you're dealing with, we obtain the parameters that complete the model, okay? So, this is where you're going to have to listen very carefully. Say we have a system of equations. Here's three equations. A plus B plus C equals 2. 8a plus 4b plus 2c equals 4. 27a plus 9b plus 3c equals 12. We're going to create these later on, but for now, you just got three sets of equations with three values and you want to solve for each value. All right, now, we're going to use this handy-dandy little calculator to do that. If you didn't pick up a calculator, shame on you, give you plenty of time. Hopefully you're able to use one online though, all right? So also, if you click on the graphing calculator instructions on the bottom left-hand part of your book, it's going to explain how to do this. Now what I'm going to do is, I blew up my screen here, and I'm going to actually show you how to plug this into your calculator so it tells you what A, B, and C are. And then we're going to find out some other things later. All right, so here we go. First thing, turn on your calculator. So we turn on our calculator with the on button. All right. Now, you're going to press the Angle Apps button. Okay, that add button is right here under the xt theta n. Then what you're going to do is you're going to select number 9, PL SMLT2, and select simultaneous equation solved. When you do that, you're going to select 3 for equations and 3 for unknowns. So you're going to slide each of those over to 3 because you have 3 pieces. Okay? Now when you do this, it's going to spit out a system of equations right here. And what you have to do next is you're going to press next, and next button is pretty much your graph button. So you press that, it brings you to the screen. All right, the numbers correspond to the numbers in front. So for instance, 1, 1, 1, and 2. So all I'm doing is I'm sitting there and typing these in. Now what happens is it pauses at the sign, so you could change these signs to minuses if you want. Otherwise, you just hit the enter button twice. All right, so you sit there and you're going to type all these numbers into your calculator, typing them all in. Notice it says plus or minus there, and the last number here is 12. 312. All right. You can go back and forth if you need to. So you can just move your buttons around here. And then after I press 12, I am going to hit the solve button. The solve button is right here. It's the graph button. So when you hit solve, it'll tell you your results. Notice the solve button is right here. All this stuff matches that stuff. When I hit solve, you get a solution. Now this solution tells us x equals 1, y equals -3, and z equals 4. All right, this is what your actual screen looks like. Now what does that mean? What that means is your a, or your x is 1, your y is -3, and your z is 4. They just use x, y, and z instead of a, b, and c. It's just different letters, but they mean the same thing. It's just going in alphabetical order. And that's how you use this calculator. So, really quick, let me explain this again. So it's not moving as quick. First thing you do is, you're going to hit the, oh, my button messed up there. You're going to hit the apps, where's the button there? The apps button, which is this button right here, apps. And then you hit the 9 button, right there. I don't even know if this is showing you. Whoop, oh, it kind of is. All right, after you do that, you're going to hit the number 2. So you go down to number 2, enter. Your equation is 3 and 3 because I have 3 equations, and each equation is 3 unknown, an A, B, and a C. All right, and then I hit the next button. The next button is graph, see it's there? So I hit the graph button. I type in all my numbers, okay? Type them all in, just type in numbers. After I type them in, I hit my solve button, and it gives me my solution. And that's all there is to it. That was obviously a different problem than ones on the board because I had to solve all these on my own. Now, we're going to do an example with this, okay? With the example, what we're going to actually do here is create the model. So we're going to create the model, then use that model to solve for all this stuff. Because A, B, and C don't mean anything unless you have a model to put them back into. So let's look at this. The table shows the quantity of V, that's volume, of air affected by the smoke T seconds after a fire started. V and T are connected by a cubic model in the form volume equals AT cubed plus BT squared plus CT. So that's my A, B, and C. So that's what we're finding. We're going to find it and plug it back into this model, give it a meaning. Find the coefficients A, B, and C. So that's what we want to find first. So we got some points here. We got our T and our V. Our T and our V, our T and our V. So anytime I take these numbers and plug them into the equation that we're going to find out, it's going to give us these numbers for V. All right, so now let's figure out how to do this. So first thing I'm going to do is I create the equation, okay? I need to find out what all my letters are. So I got none of the stuff here. What can I plug in here, though? Because when I plug this in the calculator, I don't want to have any T's there, and I don't want to have any V's there. I just want to have a number A, a number B, a number C, and then it equals a number. So when I plug 1, 2 in here, I plug in 1 for T, and 2 for V. So 2, my V, equals A times 1 cubed plus B times 1 squared plus C times 1. Now you're going to solve. 1 cubed is 1, 1 cubed squared is 1, and 1 is 1. So therefore, dot, 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 2 equals A plus B plus C. That is my first equation. Okay, we need 3 of these. So why don't you guys try to find the one for 2, 4. All right, plug that into the model. So 2 goes in for t, and 4 goes in for v. 4 equals 2 cubed plus b 2 squared plus c 2. 2 cubed is 2 times 2 times 2, which is 8. So you got 8a plus 4b plus 2c. That is my second equation. First equation, second equation. All right. Substitute 312 in now. 12 for b, 3 for t. 12 equals 3 cubed. 3 times 3 times 3 is 27. Plus 3 squared is 9, plus 3c. All right, so now I got myself my 3, 1, 2, 3. I got 3 equations, all right, and I'm going to use those 3 equations with the calculator to find out what a, b, and c are, and then that's going to give me an equation, a model. So, we just found out these things. This is the ones we just found. We said a, b, c 2, 8a, 4b, 2c equals 4, 27a plus 9b plus 3c equals 12. Where did we get these numbers from? You just did. You just solved. Solving these systems simultaneously using the technology we find. So now we're going to solve these things. You're going to take all this stuff. You're going to go back into your calculator. Okay? So you're going to take your calculator. If you have not done so already, you're going to hit the apps button once again. I like to turn this off, turn it back on to get it nice and cleared. All right, you hit the apps button. You hit 9, which is PLY SMLT2. All right, you go down to number 2, simultaneous equation solver. Equations, 1, 2, 3 equations, 1, 2, 3 variables, 3 and 3. Hit the next button. All right, you get into the system of equations that look like this. What you're going to do is you're going to put all these numbers in there. So your systems of equations, I don't feel like typing it right now for you. 1, 1, 1, 2, 1, 1, 1, 2, 8, 4, 2, 4, 8, 4, 2, 4, 27, 9, 3, 12, 27, 9, 3, 12. After you do that, you're going to hit the solve button. All there is to it. You get 1, negative 3, 4. So what that means is A is 1, B is negative 3, and C is 4. All right? Now, on top of that, you can make the model. This is our original model. Plug your A in for A, your B in for B, and your C in for C. Volume equals 1 t cubed plus negative 3 t squared plus 4t. You're not squaring this 3. So your answer is t cubed plus a negative 3 t squared or minus 3t squared plus 4t. Right? And that is all she wrote. Right? I actually just like minus t squared. I don't like to put the plus there. It's correct technically. But not a fan of putting both. Right? Exercise 4D. Use technology now. You're on your own. Now, in this case, it's a little bit different. There is only 2 points. So first thing you have to do, step 1, you have to find your 2 equations. Now, this is your equation. Y equals ax plus b. So you're going to plug in your 2 points into that equation to create new equations. All right, so the first one. This is your x. This is your y, right? 3 equals a times 4 plus b. It's just 3 equals 4a plus b. That's it. Next one. This is your x. This is your y. 7 equals 12x plus b. That's your answer. 7 equals 12x plus b. So I go, okay, now how many systems of equations I have? I have 1. I have 2 equations, right? Each one has 1, 2 unknowns, right? A and B is 2 unknowns. A, B, and C is 3 unknowns. A, B, C, and D would be 3 unknowns. So I type 2 and 2 in my calculator. So in your calculator, once again, I don't know why I have to do this. This is the last time I'm doing this on the calculator. You're going to hit, once again, you hit the apps button. You hit number 9. You go down. I'm going to go down to it. All right, enter. You're going to go to number 2. Now for the equations and the unknowns, you're going to go over to 2, hit enter. Slide down to 2, hit enter. 2 and 2. Everything else is good. Hit the next button. And notice it looks a little different now. Oh, I don't even know if you saw that. Notice it looks a little different now. All right, so you're going to type in your stuff. When you type it in, 4, 1, 3. Okay? So as you type this stuff in, you get 4, 1, and 3. All right? And then you're going to 12, 1, and 7. You always put the constant last. You end up getting A equals, 1/2, B equals 1, 1/2 x plus 1. Check your answers algebraically. Well, we can find the slope of two lines. 7 minus 3 is 4. 12 minus 4 is 8, right? Slope is 1/2. All right, y equals mx plus b. Pick one of these points and the slope. Plug in the equation. 3 equals m, which is 1/2 times 4 plus b. Half of 4 is 2. Subtract 2 from both sides, you get b is 1. B is 1. M is 1/2. Y equals mx plus b, which is 1/2 x plus 1. All right? Got it? Any questions with this lovely problem right here? No? Awesome. We're going to go to the next one. What, 2? The points 1, 7, 2, 10, and 3, 11 lie on the model in the form y equals ax squared plus bx plus c. Construct the equation in terms of a, b, and c. Now, just so you need to know, to be able to solve a system of equations, you need at least as many equations as there are unknowns. Okay, so if there's 3 unknowns, you need at least 3 equations. If there's 4 unknowns, 3 points. If there's 4 unknowns, you're going to need 4 points, because each point gives you an equation. All right? If there's 2, you only need 2 points. Can you deal with more? Of course you can, but you can't deal with less. So 3 unknowns means you need at least 3 points to give you 3 equations. So what I want you guys to do now is take these 3 points, plug them into this equation, ax squared plus bx plus c, and give me 3 equations that we're going to plug into our calculator. All right? There we go, we're done. All right, so we're going to substitute 1, 7 in, 2, 10 in, and 3, 11 in. All right, all 3 of those lovely pieces are getting substituted in here. So this goes in for the x, this is y, so 7 equals a, 1 squared plus b times 1 plus c. 7 equals a plus b plus c. All right? How hard is that? 2 goes in for your x, 10 goes in for your y. So 10 equals a2 squared plus b2 plus c. 2 squared is 4, so 10 equals 4a plus 2b plus c. Equation 1, equation 2. Third one. You on a roll yet? 11 equals a3 squared plus b3 plus c. 11 equals 9a plus 3b plus c. 1, 2, 3 equations. You're going to take those 3 equations and plug them into your calculator. This is all set up, calculator, answer. When you plug them into your calculator, your 3 equations are a plus b plus c equals 7. If you want to reorganize these, you can, putting your constants on the right-hand side, because when you plug these into the calculator, this is very important. The a, the b, the c, all are on the left-hand side, and whatever your number here is after the equal sign. All right? So, we're going to press these buttons, apps, 9, 2, 3 equations, 1, 2, 3, 3 unknowns, a, b, c. Type into your equation. So, 1, 1, 1, 7, where are we at? 4, 2, 1, 10, and 9, 3, 1, 11. All right, get them all in there. Hit the solve button. You get -1, 6, 2. Doesn't it feel good to get the right answer? A is -1, B is 6, and Z is 2. Let's create a model, hence determine the model. The model is A, -1, x squared plus 6x plus 2. There you go. Let's move on a little further. Determine the model for each graph. Now, you may go, oh no, graphs. We don't really care what the graphs look like. We just care about the equation and the points. The equation and the points. The equation and points. So, create the model. All right, model created. Hopefully it's created. X, Y. So 7 equals A1 squared plus B times 1. 1 and 1, so 7 equals A plus B. 3 equals A3 squared plus B3 times 3. 3 squared is 9. 3 equals 9A plus 3B. These right here are my two equations. When you type them in your calculator, make sure you make the equations 2 and you make the variables 2. Your system of equations looks like this. 1 plus 1 equals 7. And then 9 plus 3 equals 3. You get? A is negative 3, B is 10, so Y equals negative 3x plus 10. I don't know why it's blurry there. I think I'm losing my projector. Doesn't matter what order you plug them in either. I always go left to right though. All right, so 2 equals A2 cubed plus B2 squared plus 2C. 2 cubed is 2 times 2 times 2, which is 8. 2 equals 8A plus 4B plus 2C. Equation number 1. Equation number 2, 3, 6. 6, make sure you always put the Y first. 6 equals A3 cubed plus B3 squared plus C3. 3 cubed, 3 times 3 times 3 is 27A. 3 squared is 9 plus 9B plus 3C. That'll equal 6. And the last one, 4 and 20. 20 equals A4 cubed plus B4 squared plus C4. 4 cubed, 4 times 4 is 16 times 4 is 64A, 16B, and 4C. You're going to take equation 1, 2, 3, and plug them into system of equations. Make sure you turn the equations to 3 and the variables to 3. Unknowns to 3. Sorry, unknowns. Type everything in. Equal, you get y equals x cubed minus 4x squared plus 5x. All right. C. Look at the formula. Ax plus b over x plus c. The formula changes. Don't just assume the square thing. 5 equals 1 times x plus b divided by 1 plus c. 1 and 1. 5 equals a plus b plus c. That's easy. 2 and 4. 4 equals 2 times x plus b divided by 2 plus c. b divided by 2 is the same as 1 half b. So it's 4 equals 2a plus 1 half b plus c. Equation 2. Equation 3, the 6 and the 10. 10 equals 2 times 6 plus b divided by 6 plus c. 6a plus 1 over 6b plus c. All right, there's always just a 1 in the numerator as your placeholder. The reason we turned it into a 1/6 as opposed to b over 6, which equal each other, is because when you plug these into the calculator, you're going to plug in, where we at? 1, 1, 1, 2, 0.5, or 1 divided by 2. You can put it right in there and put equal 1, 4, 6, 1 divided by 6 equal. You would put right in here. You can do the math right in there, and it gives you the exact answer, 110. Don't put just 0.167 or 0.17. Just put 1 divided by 6 in the space. It shoots out your answer, which is y equals 2x squared plus b, which is 6 over x, or 1 over x times 6, minus 3. I like those problems. All right? 4. Table shows the distance, d meters. A scooter has traveled t seconds after it starts moving. The model connects d and t, has the form d equals at squared plus bt plus c radical t. I hope I said t's. Find the parameters a, b, and c. So parameters, find the parameters a, b, c, the coefficients a, b, c. You're just finding what a, b, and c are. X, y, x, y, x, y, when you plug it in. So you're pretty much plugging in TD, TD, TD. So the first one, 1.7 you're plugging in. 1.7, your D, equals A, 1 squared plus 1 times T, plus C1 square root of 1. 1 squared is 1, 1 square root of 1 is 1. So 1.7 equals A plus B plus C. Gets a little trickier, because now we're doing with 4. 7.2 equals A, 4 squared is 16, 4 times B is 4, square root of 4 is 2. Not much trickier. Go with the third one, 23.7 equals A, 9 squared, which is 81, 9, which is 9, square root of 9, which is 3. Take our three equations. A plus B plus C equals 1.7. 16A plus 4B plus 2C equals 7.2. And what's the other one? 81A plus 9B plus 3C equals 23.7. If you want to reorganize them this way, you may. Put them in the equation. Makes it a little bit easier if you want. You do not have to. You can leave it like this and plug it in right here. 1, 1, 1, 1.7. You guys get the point. Hit solutions. A is 1/5. B is 1/2, and C is 1. You can also put 0.2, 0.5, and 1 as well. All right. And that is problem 4. One-fifth T squared plus 1/2 T plus C, which is 1, so it's just plus square root of T. This graph shows the relationship between the height and the radius of cylinders, which have a constant surface area. The model containing H and R has the form H equals A divided by R plus B times R. A and B are what we're looking for, where A and B are your constants. Give the data points to determine the model that connects H and R. So, right here we have 2 points, and we only have 2 missing variables, so our equations are 2, our unknowns are 2. You're going to take point 2, 16. 16 equals A over 2 plus B times 2. 16 equals 1/2 A plus 2B. Next one. 4, 5. So we're going to do 5 equals 1/2, A over 4 plus B times 4. 5 equals 1/4 A plus 4B. When we type this in our calculator, we do 1 divided by 2 plus 2 equals 16. 1 divided by 4 plus 4 equals 5. This will never show fractions in here. It will always convert it to decimals. Just so. Gives us an answer, and our answer is x equals 36, y equals -1. So H equals 36 divided by R plus -1 times R, or just minus R. Right. Told you, this lesson's easy. B, use the formula for the surface area of a cylinder to explain why the model of this form seems reasonable. All right, so let's see why this seems reasonable. Anyone have an idea? Surface area of a cylinder. Anyone know the formula? Give me a hint. Make H the subject of the equation. All right. Surface area of a cylinder is 2 pi r squared, your top and your bottom, plus 2 pi r, the radius, times height. That's how the surface area of a cylinder works. So we're going to make H our what? Our subject. What exactly does that mean? What that means is we know that H equals 36 over R minus R. How do we know that? We just solve for it in A. So what can we do with this H? We can plug it into the equation. So 2 pi r squared plus 2 pi r times 36r. So I can take this, and I can actually distribute that. You get 2 pi r squared plus 72 pi r over r, so the r's cancel out, so it's just 72 pi, minus 2 pi r squared. All right, does anything here cancel? Look at that and a negative. That cancels out. Surface area of the cylinder, therefore, is 72 pi. So, that means that in this situation, the surface area of your cylinder is always going to be the same. It's always going to be 72 pi. But what happens is, because when you change your radius, you're also changing your height. That's why you can do that all the time. Find the constant surface area with the particular parameters. All right, there you go, 72 pi centimeters squared. How do we know that? We just said it. All right? Pretty easy. Use your model to find the value of h when r is 9. Can we do that? Well, we know h equals 36 over r minus r. So when r is 9, can we find h? Yeah, direct substitution. 36 divided by 9, which is 4, minus 9. Answer is negative 5. So that means our height is negative 5 when our radius is 9. Is that reasonable? No. Can you have a height of negative 5 centimeters? No, height cannot be negative. Height has to be positive. E, for what values of r can this model be correctly applied? So, r could be anywhere from 0, right? What's the biggest number this can be? Well, when height equals what, you can't use it anymore. And h equals 0, right? So r has to be, the height has to be greater than 0. The height can't be equal to 0, or else you don't have a cylinder. So we just solve this, making it equal greater than 0. So height is greater than 0, or 36r divided by r minus r is greater than 0. You're going to add an r to both sides, so just multiply both sides by r. That's going to cancel this out. Give me 36 minus r squared, greater than or equal to 0. Add r squared to both sides. 36 is greater than r squared, or r squared is less than 36. Square root both of them. So r has to be less than 6. So what this tells us is our radius has to be bigger than 0, all right, obviously, and it has to be less than 6. The reason you want to do positive or negative 6 is you can't have a negative height. So it has to be between 0 and 6 centimeters. Can't be 6 centimeters because then your height would be 0. Can't be 0 because then your height would be 0. It'd be undefined. Right? All right, that was a tough one. That was probably one of the tougher ones. This one right here is the longest one. All right. Oh, actually, this is the last problem anyway. Last one toughest, this one's longest. So the cross section of a mound on a bike track is shown. It can be modeled by the function. Oh, look at this: ax cubed plus bx squared plus cx plus d. Now we have d. For when x is between and equal to 0 and 20. Units are in meters. So first thing we're going to do is we're going to state the value of d. Is there a way we could find out what d equals? All right, how do you find d? I can go right away and tell you. All right, so d is your y-intercept, right? When x, b, and a all equal 0, what's d? There it is. Your y-intercept, d equals 5.209. Whatever your y-intercept is whatever does not have a variable attached to it. Use the terminology now to find a, b, and c. So now we can find a, b, and c. But you may say, wait a second. 1, 2, 3 points. I have 1, 2, 3, 4 variables. So what do? Watch. You're going to plug in your y. 7.264 equals a times 5 cubed plus b times 5 squared plus c times 5 plus 5.2 is 9. All right, you're going to solve this. 5 cubed is 125, 25, and 5c. Now, here's the problem. I can't plug this into my calculator. All right, I got my a, b, c, my x, y, z, right? But I have no, this isn't a fourth variable. There's no variable here to solve for. So I can't do that. So what do I have to do? Is there anything I can possibly do? Give you a hint. What can I do? You can actually subtract, and you can't subtract. You're going to subtract this 5.209 from both sides. All right, 7.624 minus my d equals 2.055. That's my new constant, equals 125a plus 25b equals 5c. Now I can plug this into my equation. Got it? do the other two now. We should be able to do the other two. All right, next one. 5.719 equals a times 10 cubed plus b times 10 squared plus c times 10 plus 5.09, right? 1,000, 100, 10. What do we do with this number? We're going to subtract again 5.209 minus 5.209. That gives us our equation that we're going to use. These are the equations we care about. Equation 1, equation 2. 0.510 equals 1,000a plus 100b plus 10c. All right? Next thing we're going to do. What do we do next? We're going to type in the next one. 2.824 equals 15 cubed. 15 squared, 15 plus, don't forget to add your d. Expand the 15s. What do we do with this number? We're going to subtract, once again, minus 5.209 to cancel that out, minus 5.209. Now watch what happens here. I get a negative number. Is that allowed? Of course it's allowed. And we're going to go put the negative number actually in the equation. Negative 2.385 equals 3,375a plus 225b plus 15c. Type it all in your calculator. 125, 25, 5, and 2.055. 1,000, 110, and 0.51. 3,225, 15, and negative, not minus, the negative sign, which is the bottom right-hand side, 2.385. Even though you don't see it there, you can say, put it in there. You're going to solve, and you get a solution that looks like this. And you'll be like, oh man, that's wrong. But actually it's right. It's 0.003, negative 0.117, and 921,000. I should have said 3 thousandths, negative 117 thousandths, and 921 thousandths. The reason I did the decimal is my thousands and thousandths sound the same. All right? Wow, that was fun. Get one more, we're not done yet. So, that's part, the cross section of the mound, same question. Find the height in meters. So we have this equation, right? What do we do with it? Huh? What do we do with it? Mark what that. We plug in 20, right? Point E. Point E is when x equals 20. Plug 20 in for x. This is why we made the model to solve. What do you get? 0.829 meters. Does that make sense? About 1? Yeah, it makes sense. Whoops, sorry. And that's it. That was pretty easy, wasn't it? Systems of equations. You guys masters? Calculate. It's going to be your best friend. Learn how to use it and you can solve all this stuff very easy. Don't learn how to use it, you're in trouble. Anyway, great lesson today. Glad you guys learned because I know you did. And next is the review. So until then, see you guys later.